So I think the simplest way to find the gradient of this line is to rearrange and have y equals mx plus c. So we start off with 2x minus 3y equals 6. I'm doing some basic algebra rearranging to get y as the subject, and y is then 2 over 3x minus 2. It should be fairly obvious to you by comparison with y equals mx plus c, where m is the gradient and c is where the line crosses the y-axis. So in this case the coefficient of x is m, so that's the 2 over 3 here, so that's the gradient. So the gradient is 2/3. For part B, I'm looking for a line that's parallel to L, that's the first thing to note, and it passes through this point. So I'm going to use those two bits of information separately. The first piece of information is that if the line is parallel to L, it must have the same gradient, so the gradient's also 2/3. That means if I was writing down the equation of this new line, I'm going to write it as y equals 2/3 x plus a constant, and that's going back to this y equals mx plus c. Now at the moment I don't know what that constant is, so the next step is to find out what this c is. So what I'm going to do is I'm going to substitute x equals 6, y equals 9, that's this point. Okay? At this point x equals 6 and y equals 9, and if we put that into this equation, because this point lies on this line, we should be able to find c. So I get 9 is 2/3 times 6 plus c. I work it out and I get c equals 5, and so now I can do my equation of the line. Y equals mx plus c, 2 over 3x plus 5. That is fine as a final answer, although there are different ways of writing it just by a bit of rearranging. This is more looking ahead to sort of A-level work. You could rearrange it and there's different ways you could write it. 2x minus 3y equals minus 15, or 2x minus 3y plus 15 equals 0. But this is just an aside. Your final answer can be this one down here.